To finalize the discussion of file systems, we'll talk about access control lists. We're not going to go into a whole lot of detail here. It's just a way to manage granular permissions for files. So let's look at some examples. On my CentOS system, I will change to my home directory. The first thing I'll do is just touch a new file called File, and I'll list that file's contents. So this file has read-write for the user, read-write for the group, no execute, and read for everyone else. But what if I wanted to give a very special permission? What if I wanted to give B. Whaley access to read this file, but B. Whaley and Vagrant aren't sharing a group? How could I do that? I couldn't do that under the normal Linux access control model. So we need to use extended file access control lists, the POSIX access controls as they're known. To do that, we can use getFACL to get the current ACLs on the file. So I type getFACL file, and it shows me just what we talked about. The user has read-write, the group has read-write, other has read. Now I can say set FACL, and I use -m, user, B. Whaley, read, write, x. So I actually want to give B. Whaley read, write, and execute permissions to the file. Now if I get FACL on the file, I can see that the user has read, write, except for B. Whaley, who has read, write, execute. Special permission. Group has read, write, and then there's this other field. So if I do ls -l on the file, notice that there's just a funky X here showing, well, somebody else has permission to execute, but we don't know who that is because the standard access control model doesn't leave a space for that in the output. There's also a plus sign at the end indicating that there's additional controls available to you, additional file permissions, which we can, of course, view with getFACL. So look at man pages for getFACL and setFACL for more examples.